The Build Show Build Boston series is sponsored by Allura Fiber Cement Siding, Mitsubishi Electric Train US, Roseburg, Schuco USA, and Warmboard.
Hey, Steve Basic Architect here. We're out here at Build Show Build Boston site. Yes, concrete footing day. It's the start of the project. It's the very first piece of the puzzle that actually gets constructed. Everything sits on top of the footing. The footing is basically the feet of the house, and that it's the first piece of construction to happen, and you really get a sense of the extent of the house. Now, granted, things get bigger, smaller as we build it, but this is like the first time where we get to see the house and the size of the house relative to the job site. So you can see all the footings are in place, the interior footings are here. The concrete truck, pump truck, just pulled up. We're waiting on the concrete truck to get some concrete. And then we'll dive in there and we'll start seeing the footings get poured. All right, so I jumped down in the hole here. Just before we start getting into the actual casting of the footings here and talking about concrete and seeing the concrete roll out, I want to jump down in the hole, talk about a few of the details. So you can see behind me here, there's a whole bunch of rock outcropping. So we were pretty fortunate for about 80%, 90% of the project here, the excavation. It was through simple dirt, picked up a few smaller rocks, nothing that the excavator couldn't handle. But when we got to this back corner, you can see it was pretty much solid rock under here. So we had to get the hammer out. They had to hammer at it, dig that out. But nonetheless, we're here. We got our footings in place. We're ready to go. We jumped over here at the corner. I just want to go through a few things about the footings and all the internal structure and everything before we put concrete on it. This is kind of our last chance here to see exactly what's in place and what's happening here. So obviously you can see the footings here. These are an aluminum footing. There's a little release oil that they spray on the inside of that so they can just pull them off the concrete real easy. You can see down inside here, we have those yellow spacers, but they're also reinforcing chairs. So you can see that they hold the reinforcing up a bit off of the bottom of the footing. Now, the rebar we want to put down in the bottom third of the footing near the bottom where the rebar is actually helping in the tension forces. So as we apply weight, that footing wants to bend at the bottom, and because concrete works well in compression, we don't really need any rebar at the top, but at the bottom of that footing, where the footing is in tension, that's where we need that reinforcing to kind of give that added edge to what the concrete can't deliver. So we have the reinforcing in there, and then we have, you see here, we have these L-shaped bars that come up through the middle. They're all tied to a series of rebar. They're tied down to those bottom bars. Those are basically, when we cast the wall above it, these keep the wall from displacing across the top of the footing, basically sliding off the footing, right? So we have those rebars. I grabbed a couple of the rebars here, and you notice right off the bat that there's basically two different diameters here. So when you talk about rebar, we call this number 4 bar, number 5 bar, but what we're really saying is the number 5 bar is measured in eighths, 5/8 of an inch in diameter. The number 4 bar, 4/8 or a 1/2 inch bar. So you have the 1/2 inch bar and the 5/8 bar, but we call them number 5s, number 4s, respective of how many eighths the diameter is. So we use the larger bar at the bottom, and then the smaller bar is the one that gets bent into those L's. And the specs on these are called out. We have that 12-inch leg there, and then we call for a 30-inch leg on the vertical there, because there's a certain amount of concrete we need to capture there to make it an effective connection there between the concrete. And if you notice, actually, on the bar, it's not a smooth bar. It actually has this knurled edge. And what that knurled edge does is it increases the surface area of the reinforcing bar, but more importantly, it gives that concrete something to bite on and not be able to just freely slide across that bar by having that rougher edge there. So, the other thing you'll notice in here is I called for a 4-inch PVC pipe that gets fitted between the footing. Now what that does is it connects the inner part of the footing to the outer part of the footing. In this project here, there was a house here, and the old house had some water problems down below. Now, what's interesting to me is if those water problems were something that were actual water problems, or was it a drainage water management problem? I think it was the latter, but to be sure, we put this in, it equalizes that hydrostatic pressure across from the inside of the footings to the outside of the footings. We'll have a perimeter drain that runs around the outside of the footings that we will trench to daylight, meaning that everything will just gravity flow out to the bottom of the hill somewhere over there. And on the inside, we'll have an interior perimeter drain that'll go to a sump pump, and we'll eject that water out vertically through the sump pump if the water challenged that slab in that way. Now, the beauty of having these pipes, you see there's one there, they're down there. They're pretty much in every straight run of wall. And the reason for that also is let's just say that the exterior perimeter drain got clogged where I'm standing. Well, it allows water outside of the wall to basically flow inside, come down here, and then flow out that pipe and get to the outside. So by having all of these internal pipes connecting the inside and the outside, it basically allows the water to rise and fall at a completely level situation, regardless of whether you're inside or you're outside of the footing. So I think that's pretty much it. We have one little thing to talk about. You can notice there's all these little orange stakes down there. That little orange stake is what the surveyor puts out here so that the builder and the concrete guy can identify the corner of the wall above. So basically right where that stake is, we can assume that this is where the outside corner, it's an inside corner, but the outside of the foundation wall will occur right here. So there's a lot of people that are at play here. It's not like you just do some quick drawing and hey, it gets laid out. I do the drawings, I lay out all this information, spec this stuff. The general contractor works through it. The concrete subcontractor goes through and gets all the rebar and everything just right. The surveyor's involved in getting us in the right location. And when the footings are then cast, the surveyor will then come out and he'll put a nail in the top of the footing that symbolizes, again, the corner of the wall so that the foundation guys know where to set up those forms so that we can talk about the wall. And we'll talk about that a little later when we're talking about the foundation wall systems. But I think that's about it. They're getting the pump truck ready. We just need that concrete truck. Let's go cast some footings. As we were moving around, I thought it would be really great. Let's talk about the interior footings. So we have that long perimeter footing, which is like, I would call it a ribbon footing, which basically traces the perimeter of the house. But for any of you that own a house or live in a house, chances are if you go into your basement, you're probably going to go in there and see a series of columns. Well, those columns don't just go down to the concrete slab typically, they go down to their own private footing. So you can see here we have a bunch of interior footings. Now, the interior footings get their own reinforcing. So I just use the analogy here where if you think about the forces that are being exerted down on this footing, there's this structural terminology called puncture shear. So basically we have a column here. The column has a specific load to it. It's pushing down on that column. Well, the column wants to push through this footing, right? because the whole idea of structural system is that all of the weight comes down and the ground pushes back. And that's what keeps our buildings from falling down, right? Basically, everything gets put on the ground. So this idea of puncture shear, if we use the analogy of I put a 4x4-inch piece of paper in my hand and I take a pencil, and the pencil represents the column. If I push the pencil down pointed edge first, I can push it right through that piece of paper because the amount of surface area that's being exerted against that weak piece of paper is very small. So it creates that puncture and goes right through it. So the way that I battle that is twofold. I can make the paper layer stronger, like I could take that single sheet of paper and make it 20 sheets of paper glued together. Now the pencil would have a harder time. Or I could do that, and if I turn the pencil around and tried to push the eraser through the 20 sheets, you can see how much more of a challenge that'd be. So it's basically the same analogy here, that we have this 3 foot by 3 foot footing, or 9 square feet of concrete footing. It gets reinforced at the bottom. So rather than do multiple layers of paper, I'm just putting a steel cage at the bottom. So this has 5 number 5 bars, and you remember from the previous video, number 5 bar is a 5/8 inch thick bar, and it's 5 number 5s each way. So there's a nice grid pattern here. That lolly column will come down through the middle. The lolly column is 4 inches in diameter. So it's going to have something like, I don't know, about 15 inches of surface area that's in contact with the footing. But as that force gets exerted down through here, that load gets spread across this 9 square feet. So we've taken that little 4-inch diameter circle, and via this footing, we're able to spread it. Hence the name spread footing, right? Basically spreading that load out and distributing it on a larger area of the ground, and the ground pushes back, and hence we have a successful structural system. All right, so I moved over to the east side of the house, and I wanted to talk about a couple things that are happening here that are somewhat atypical to the foundation. You notice here we have the house foundation is this inner line. That's part of that ribbon footing. But notice we have this outcropping that comes out here, and it's a secondary footing. You're probably wondering, why do we have 2 parallel footings here happening here? Well, the reason is we're going to have 2 parallel foundation walls. Basically, I'm standing in what will eventually be backfilled and have a concrete slab somewhere up here that we're going to call the garage. But we have a staircase in the garage that will come down to the basement in the southeastern corner over here. So we have the foundation wall that's actually holding up the house. This side over here, these 3 sides, are only going to go up to a pre-prescribed elevation that's set just slightly above the slab in the garage, and that'll provide us with the opportunity to come down here with a staircase and get access to the basement from the garage. And right over here, because we're talking about the garage, you can see that there's a difference in elevation here. Now, typically when you have a basement, there's no need to go down the full 9 feet to put a foundation wall in for a garage, because that foundation wall is going to get backfilled and only needs to be 4 foot. The bottom of the footing needs to be 4 foot below grade for frost protection reasons. So, in an effort to do that, you can see here, we basically have this change in elevation in the footing where the actual wall will get poured at the 9 foot down there, but up here, it'll only get poured as a 5 foot stem wall that'll breach through the ground about a foot, and then that'll trace around and come all the way around, and then we have another step footing on this corner of the garage over there that brings it back down to the house footing. So simply a step footing. We have some rebar in there to help pick up the load, the structural load inside there, but that's how we deal with that elevation change and provide some efficiency in our concrete foundation for the garage, which has no excavation below it. All right, you can see the concrete truck is pulling up. It's perfect timing. The pump truck is in place here. Let's cast some footings. Got my good buddy Jared here. Jared is half of LDS. They're the general contractor on the job site. Jared, we got a great day happening here. It's concrete footing day. So tell us a little bit about what we got going on here, man.
We're really excited to get this job started, Steve. We got Walsh Forms out of Westwood helping us out. They do all of our work. Larry Walsh, the owner. These guys are exceptional. They use all aluminum forms, aluminum footings. They have all their bar in, all their uprights. We're really excited to get this started.
Now, that's awesome. And you know, we shot a whole bunch of video here. It's an exciting day. We got another concrete truck coming up here. We got the pump truck there, placing that concrete out there, making these guys, you know, job real easy. So let's get down in the hole and see some concrete get cast.
All right.
All right, so we're down in the hole, we're casting the concrete. Obviously a bunch of guys doing a bunch of things, but I want to call your attention to 3 guys. There's 2 guys that are walking around with these sticks, and it looks like they have a calculator on the outside of it or stuck to it, and you can see it there, and you might be able to hear some distinct beeping. And then you have the guy with the hose here. So the guy with the calculator on the stick, it's actually what it's registering back to is this GPS system, right? So we're able to put in the coordinates of elevations for bottom of footing, top of wall, all of that. And the easiest way to do it is you set this up, calibrate that metering device, or the eye basically, to this, and you set it to the perfect height, and then all they have to do is walk around, and when they hear it beeping, they know they're at the right elevation. And if it's sitting on concrete, then obviously we have the right height. If there's a void under it, we got to put more concrete in. But it allows us to go around and check the elevation of the footing as it gets cast so that we're pretty much set level. And then you see we have a secondary one here that as they start to tool it, rake it out, get that concrete to start setting up just a little, they're able to manipulate that elevation just a little bit more and then do a double check there. Now, the guy with the hose, that's a vibrating system. My analogy there is all of us have either probably baked something and or watched our moms bake in the kitchen, or dads. And what do you do when you have that pan of flour and you're trying to level it out? Well, you tap the side of that mixing bowl and it kind of levels things out, right? Basically, you're putting a vibration in that mixing bowl to get a level. Well, we can't sit here and go around and tap the side of the footing with a big enough hammer without damaging it. So you basically insert that hose, it puts a vibration in there and basically works out any of the air bubbles, any entrained air inside that system, and gives us a really nice densely packed concrete inside the footing by running that through. So you can see we have the guys doing the rough stuff up there. We get it rough checked, and then out here you can see there's one gentleman that has the trowel, and he's basically doing the finished footing, setting it up to be nice and smooth so that when we come to lay out the wall panels for the wall foundation, it sits down on a nice level smooth surface so that we can continue our work right from the bottom up. LDS is doing a superb job out here. Walsh Concrete, the guys doing this concrete, you can see we got an army of guys. Everybody's got a job. Everybody's doing their job very, very well. So let's go down there and see a little bit more of the work. All right, so we're out here. This is the garage foundation. Now, one of the differences between this and what we talked about down below is, notice there's no vertical bars coming up here. And you're probably saying, Steve, why is there no vertical bars on the garage? Well, down there, you have to understand our foundation wall is acting like a retaining wall. We have the footing, the foundation wall, and we have dirt on one side. Well, that dirt is exerting a lateral pressure and wants that wall to slide off of the footing. Here we have a different situation. we have our foundation wall, but we have dirt on both sides that are equalizing that lateral pressure. So there's really no place for this wall to go. So the structural engineer didn't call out for any of those J-bars here because there's really nothing to slide left or right because the ground's holding it in place on both sides. Now, over here, you see we have the footing, but notice that they stopped. If they just kept pumping concrete in here, it would just literally fall out the bottom side. So they put enough in there to close off the chute down the bottom. They're gonna let that set up a little, and then they'll come in here and they'll fill in this void with some additional concrete, and they'll go down there and tool it and make that connection. But that keeps that from just wanting to fall through, and that's just one of those tricks of the trade that, you know, when you're the concrete guy, you know that trick. Alrighty, 550 linear feet of concrete footing in place, done. Let's strip the forms tomorrow. Let's get those wall panels here, and let's start setting some foundation walls. HD Basic Architect, Build Show Build Boston. We got pump truck, we got concrete formwork, we got concrete trucks coming up the driveway. It's foundation day. Let's get going. Watch out here. Hey, so we jumped up here. Just want to give you a quick understanding of what's happening here. This is the garage, so this is all going to get backfilled eventually, but you can see we have these jams here. You can see they line up. It's basically, this is one of the garage door openings, so they put these in between here. Those will get filled to the right height. These, they'll leave it a little low so that when they pour the slab will just roll in down and sit down on top of the foundation wall here. It'll be a little bit of a rough wall, but that'll be a cold joint that's down below grade, typically how it's done, so that you get that kind of monopour. Take a quick look in there. You can see some of the reinforcing. You can see these are aluminum forms, 10-inch wall. We have our spacers there that are basically providing the 10-inch width, but they're also locking the panels together to keep that lateral pressure from the concrete that gets placed in there from spreading. So great forms. Can't say enough about the subcontractor out here. They're doing a beautiful job. So let's go over and check out some other stuff. I came down in the hole here because walking around the top, looking down on it and looking across at it, you just don't get the same perspective you do when I'm standing down in the hole and standing next to these 9-foot aluminum forms here. So 10 inches thick. We got about 140 yards of concrete going in here. I don't know, 550 linear feet of foundation wall. We got a lot going on today. It's a full day for the concrete guys. We got a bunch of little things to show you, different aspects, different parts of it. So let's get after it. All right, we're on the back side of the foundation. You can see Larry, the concrete subcontractor, and his crew are here. We got the boom truck bringing the concrete over. We have about 550 linear feet of foundation wall out here. That equates to about 130, 140 cubic yards of concrete coming our way. We got a truck coming every 15 minutes to just keep that pump, just keep it rolling. We got parking spaces for 2 trucks, so that hose doesn't stop until we're pretty much done with the foundation. One of the things that you strive for is that everywhere we're putting concrete, we don't want to let it set up too long and develop what's called a cold joint. So we want to make sure that that concrete is basically one monolithic pour as we go along here. So anyways, let's jump down. We'll talk about a few other things. Hey, so we're on the back side of the foundation here. you know, we got trucks, we got concrete coming, they're casting the walls over there, but I thought it'd take some time because a lot of people think, hey, you throw up some forms, you throw some concrete in it, you peel the forms away, you got a foundation. But there's actually a real science to putting this together. Now, this isn't your average house that's just a, say, 42 by 24 foot box, 4 corners, you know, 2 sets of parallel walls. You can see here, there's a lot of little 2-foot jogs. There's a lot of what I call coastlining happening here. So that poses a little bit of a challenge in that from one side of the foundation to the other, we're probably at something like 160 feet or so in full length, but that foundation is moving in and out. 2-foot jogs here, 4-foot, 6-foot jogs. How does Larry, the subcontractor, ensure that those walls are parallel? So you can see out here, there's a number of strings. You can see there's 3 green going the full length of the house this way from the garage, and then there's a red one that flies up there. So they use the strings to identify the straightness of the wall, as well as setting up for this coastlining. Here you can see we have that 2-foot jog. Well, we have a green line that's 2 foot over. So they can take measurements here, they could take measurements down there. They set up those parallel lines, and then they set the form work to those parallel lines. And what that ensures is that this wall, and that inside wall, they're all going in the same direction, that they're all perfectly parallel, and the proper offsets have been accounted for. So that takes care of the undulation of the walls, but how do we know that the walls are at the right height, or what height to pour the foundation wall? So Larry has 9-foot forms, we have 9-foot walls we asked for. He has 9-foot walls here, and they basically pour to the top and screed. But how did they identify where the actual top of the wall was? Well, welcome to the laser site here, right? So they set this up, and they have the ability to scan the full foundation, all 550 linear feet of it, and get an understanding on where the top of the wall is relative to the laser. So Larry told me they checked it this morning before they poured, and all 550 linear feet, they're within about 1/16 of an inch in elevation for the top of the wall. So if they screed to it, we should have a pretty true wall happening there. Now, the last piece that in my chat with Larry is, you saw in some of the previous videos, we had the surveyors come, they put a nail in the top of the footing that basically sets the outside corner of the wall. If we walk up here and look down at the corner, you'll see there's actually wooden blocks. They're nailed into the footing. So they basically set that corner of the foundation work there and then put that 2x4 block and nail that into the concrete footing, so that we know that that corner is in the right location and it's not going to move, and it's going to be true to that location throughout the process. So it's really great to work with pros like Larry and the guys under him, in that, you know, we don't get a true appreciation until you come out here and you stand alongside these guys working hard, but just putting an absolute science to this process and ensuring that we get the best foundation wall we can. So hats off to Larry. You know, an interesting thing about when you're pouring foundation walls is you don't get an appreciation for the process, right? So we'll start with how we get concrete. Obviously we get concrete here by the trucks, but there's a huge coordination effort between LDS Construction and Tresca Concrete. We got concrete trucks arriving every 15 minutes. We don't want to have any of that concrete sitting there without new concrete getting mixed into it in the formwork and developing a cold joint. So you see here, we got the pump truck. We got 2 concrete trucks dumping into the bin there. The auger's throwing it up the chute. We got a truck here that just emptied, and he's washing out. And then we got a couple trucks down on the street there that are waiting to come in and replace the 2 here. So it's this constant movement of concrete from the batch plant out here to the job site so that these guys, Larry, can do their job. And you can see here, it's kind of an assembly line that moves along the foundation. The foundation wall obviously doesn't move, but the people do. So you got Larry dropping in the concrete, and he's got some guys helping him move it around. We got a guy doing basically the rough grading or rough screeding and making sure that the concrete is at the right level. And then as we move down, you can see we have a gentleman with a trowel there doing the finish screeding. And then we have the two guys down at the end there that are measuring out, and they're dropping in the anchor bolts. We'll grab one of those and we'll talk about that here in a minute. But you can see it's like an orchestra in action out here. These guys, they all have their jobs, they know what their jobs are, and they're making it happen out here at Build Show Build Boston. All right, you can see we're over here, we have the top of the wall has been screeded. Now the guys are applying the anchor bolts. I grabbed one out of the box. These are 5/8 of an inch in diameter. They're 12 inches long. We're doing a double mud sill here, so they're gonna stick out 4.5 inches is the plan. So that's 7.5 inches. On the drawings, we call for a minimum 7-inch embedment, which means how much of it is actually buried, right? So we get 7 inches. You can see there's a little J hook down here. So when you push it in the concrete, that aids in that pull-out strength when the concrete cures. Around it, we have the threaded top here. Basically, it just gets a washer and a nut to screw down the double mud sill. Now, the interesting thing about anchor bolts is, depending on your location, sometimes the spacing has to be closer. Sometimes we use a 3-inch square washer when we're near the ocean, high wind areas, etc. Because these anchor bolts are basically what connects the whole house to the foundation wall. So you can see here the spacing of these. Typically you put a bolt within 12 inches of the corner in each direction, and then we're running them about 32 inches maximum there. I believe the code allows you to go up to 48 inches. Our structural engineer likes to tighten that up a little bit to a 32-inch max spacing. So you can see those getting put in. So you can see John over there, they actually have a template made up. They measure out where the bolts go, and then they have this little jig. The jig does two things. It sets the displaced distance from the outside of the form, but it also sets the height of the bolt. So you can see all of these bolts, we have a nice uniform straight line as well as a uniformed height. So again, the science of the process here is just so intriguing when you get to come out and hang out with these guys. Over the years, they just develop all these little tricks and techniques. And, you know, in a couple days, we'll strip the form, everything will be perfect, and you'll be like, oh yeah, that wasn't that hard. But it's tips and tricks like this that make it perfect. All right, we're over here at the southwest corner of the house. Now you see the concrete guys working on the foundation, but I want to come over and talk about exactly what's happening here. You can see we have the taller foundation walls, and then it drops down inside there. So what you're basically looking at here is we have a bedroom planned for the inside of the basement there. We have a future bedroom, fitness room planned for that side. We have 2 windows that are going to go in that light well there, and they have to be an egress window so that if the place catches on fire, someone that's sleeping in the bedroom can come over. The windowsill isn't higher, the opening of the window isn't higher than 44 inches off the ground, and they can climb out into the light well, and we'll have a ladder in there so they have the ability to climb out in case there's a fire and get safely out of the basement. So though we have those 2 windows, so we had to drop this because this section here is going to be set down at grade or slightly above it, and doesn't need to be the same height as the foundation wall there beyond. So they cast that somewhat separately. You can see we have the end dams, and then we have a little cap there to help cap the top of that wall, but that's what's happening there. This will all get backfilled. That'll get a drain in it, get backfilled with some stone, and we'll be all set with our egress windows in the basement. I got Jared from LDS Construction. He's half of the general contracting crew, him and Kevin, but we got a busy day today, buddy. We got trucks coming, we got trucks going, we got pump trucks delivering concrete guys. Now, these are guys that you work with regularly out here, right?
Oh yeah, we try to keep everything tight, Steve. This is perfect. Foundation day. We finally been working hard to get this here. You know, a lot of effort's gone into this. We got Walsh pouring the concrete for us in the forms. He set everything up with all his aluminum form system. We got Guarini here doing the pumps for us, putting it wherever we need to put it. And we have Tresca Brothers supplying us all the concrete today. So this is our local group. Everybody does a great job, works together, comes together for a great team.
And I would imagine in today's world of construction, like having a great team that's loyal to you and then in turn you're loyal to them just makes for a really good collaborative effort and helps move this process along in challenging times.
Without a doubt. And I know what they're going to provide to us. I know the job he's going to give us. I know how he's going to set up the guys who come behind him. And the other thing is, we know he's going to show up. We know he's going to come do the work when he says he's going to do it. It means a lot to us to be able to keep a schedule and get the work done as nice as these guys do it.
Yeah, I had a quick chat. Larry, the owner of the concrete, Larry's spot on, man. He knows his stuff about concrete foundations.
Not his first pour.
No, and it was great having a conversation. And you know, I always find myself, I come out here, I see all the strings, and I have conversations with him, and I just get a tremendous amount of knowledge from these guys that do it every day. You know, you got the guy over there with the little wooden jig set up for the anchor bolts. It gives the proper displacement, it gives the right height, and they don't have to think about it. They just move along. So it's a great team you got out here, and yeah, let's get a foundation and let's start framing.
That's it, man, and we're just getting started. You're gonna love everybody that come behind these guys too. So we're really looking forward to getting this thing up out of the ground. This is such an important aspect of it. We're really happy to see this going today.
All right, so made it back to the studio, grabbed one of the details. Out of the drawings, I did strip off a little bit of information because I only wanted to talk about the pertinent information that we will be talking about based on what you saw in the videos out there. So you can see here, there's our 10-inch foundation wall. It extends 9 feet. You can see 9 feet, 10 inches wide. That sits on top of a 2-foot footing, 10 inches tall. Basic structure of the footing, you saw it out there. We have a couple number 5s that run in the bottom. And then we have these, I call them the J bars, that run up. They make the J, and then every other one switches direction. We also have a number 5 bar down in the bottom of the wall, one at mid height, and then a couple up at the top of the wall. And you remember on the top of the wall there, we called for our anchor bolts, and they have a 7-inch embedment, so they're at least 7 inches down in the concrete, and we'll attach our structure to that. So that's basically the physical mechanics of the foundation wall. Pretty simple. You know, in New England we do even though we have the J bars, it's been somewhat of a nostalgic tradition to run a keyway in there. They basically just drag a 2x4 through there and get a gouge a groove in there to, you know, the thought was this is gonna help with some lateral displacement of the upper wall relative to the footing, but these J bars are really putting the bar in shear there and keeping that lateral displacement down at the bottom of the wall. Now, one of the things you'll see here is we call out on the outside wall here on the face here we have a 60 mil polyguard waterproofing, And then on the outside of that, we have this dimple mat that actually has a filter fabric attached to it. And that goes over the top. And remember that polyguard, it actually comes down and does that. So it covers that joint. And you know, polyguard has a really good system because they have that one material there that comes in the sausage tubes that you can fill in any of the oversized cracks, as well as you deal with that cold joint with it, and then you put the polyguard over the top of it. But I want to talk in general terms, right? So some of you have heard me say it before, but we call it water management. And so the term water management, there's actually kind of two phases to it, or two aspects to it. One is at some place we need what I call the Alamo. And the Alamo is basically where I stop the water, right? So the Alamo is where it stops. My intention is to not let it go any further. Now, but the second phase is probably the most important. The second phase is, what do we do with the water when we stop it? We have to provide a path. Now, I'm going to inject a word in here, right? We need to provide a successful path. And I say that because I've seen a lot of projects that have failed, basements that have flooded, water management concepts for foundation walls that they provided a path, but I wouldn't really have considered it a successful path. So we want to provide a successful path. So how do we do that? Well, we're actually going to get water from one of two ways, right? It's going to rain, and water is going to migrate down into the soil, right? I mean, we can slope the ground away, but still, there's going to get some migration of that water in. But we also have this idea of groundwater that's going to come up via hydrostatic pressure, right? And who knows? I mean, that water level could be almost anywhere, depending on your site, right? I've had projects where they're virtually bone dry, pretty much like this one, which I would consider low risk. And I've had ones where, you know, the water is down 30 inches. And so in a 9-foot wall, that means you still have 6.5 feet of head of water against the wall trying to find a way in. So not the best of situations. That one would keep the sump pump working full time. But if you recall out there, we put in these laterals. So you saw those getting put in the concrete. Those are nothing more than the 4-inch PVC pipe that gets just at the bottom of the footing. Right? So that just gets placed in the footing. Basically what it's doing is it's connecting the outside here to the inside. And you notice that there's two things that these two, inside and outside, are pretty much synonymous, meaning that we have a bed of stone here, and it's wrapped in a filter fabric. And on the inside, we also have a bed of stone here. Now, the inside, we actually have a perforated pipe. You can see it's called out there, 4-inch perforated pipe. This one here actually comes with a drain sock on it, meaning that basically the filter fabric is around the pipe like a sock, if you will. And that keeps, you know, the finer, siltier stuff from getting in and clogging out the pipe. But my point here is that when we have these two inputs for water that I have to manage, the groundwater, that's a pretty easy one. We put the polyguard on here, And the PolyGuard is my Alamo, right? And you can see that there. 60 mil PolyGuard waterproofing. So that gets applied to the face of the foundation. Basically, it's a dam. Any water here that's trying to move and migrate in that direction, it stops it. No water is conceptually not allowed into the foundation wall. And with that, we need to provide a successful path. How do we do that? Well, we have this dimple mat, drainable dimple mat with a filter fabric here. So any water that migrates up against the foundation wall will then come down and fall and get into this stone pad. This gets held up just a little, so the water has the ability to migrate in. And if you think of this stone pad here wrapped in filter fabric, well, that's just basically a water pipe sausage, if you will. So water has the ability to migrate laterally through that. Water has the ability to migrate up and down through that stone, right, and go high. So we take that water, we bring it down. Now it's in our sausage tube of stone down here. I don't necessarily want to leave it here, especially if the rise is high enough where it starts to challenge that cold joint between wall and footing. So that's why I put in these 4-inch PVC. I think I called them laterals at the job site. So these laterals are doing nothing but connecting the outside to the inside. So as water migrates down here, it fills up to a level, but as this tries to fill, that water, because it searches for a level, is going to go through the lateral pipe, and it's going to level out with whatever water is happening on the inside of the footing, basically under slab inside the foundation wall. So as that water rises, it's going to spill over into the pipe. The pipe is going to take it away to a sump pump. The sump pump is going to eject it to the outside and get rid of the water and move it away a significant distance away from the foundation. Now, because our house is a one-story ranch, we actually have a dry well system in the back of the house, and then on the front of the house we will have a drainable system to daylight. And what I told the builders is the back system versus the front system. The front system will basically be plus 1 inch higher on the sump pump. So that is nothing more than basically shimming the pump inside the sump basin. Now, the reason I do that is because I want most of the water to get retained on site per the direction of the jurisdiction that we're in. So it's going to go up, it's going to go into this dry well Coltech system in the backyard and basically perk like a normal septic system would perk back into the ground. So we're just moving it away from the foundation and providing a path, and we're putting it into the ground at a safe distance, in the understanding that as that water perks into the ground, it's actually going to perk into levels below the foundation, so it's not going to challenge us. But the outside water, like I said, comes in, hits those laterals, and if that interior lower sump pump, the one that goes out to the rear, well, if that one fails, the water will just simply rise an inch higher, and when it does, it'll fill up the basin and hit the float on the front sump pump, and we'll eject that water out into the front yard and let it perk off the surface of the ground. Now, the reason for that is if the homeowners drive up and they see the water coming out of that pipe to daylight, it's going to be something that they recognize, but that's also going to be an alarm to understand that the rear sump pump has failed and is no longer working, and that the primary pump has shifted from the rear to the front. I have the same system at my house. It works really well. My front drains it across my driveway, so in the 26 years of living here, I have driven up a couple times and I've had water across my driveway, and I immediately know that my primary sump pump, the one that's out back, has failed. The front one has kicked into service, and I need to give some attention to the former primary sump pump in the back of the house. But that's the reason for those laterals, is basically we're just trying to equalize as this water migrates up. And you have to understand, groundwater is a uniform load, right? It's not a point load, right? Groundwater is not a leak. Groundwater is a full frontal attack in a uniformed manner. So it's basically, the water level is just trying to rise in the ground. It is not a giant point load in one place. It doesn't have the ability to do that, right? It is a uniform load that is trying to push that whole water level up. So that lateral just gives me what I term a successful path in combining the outside stone to the inside stone, and that gives us a very successful system. Dual sump pumps going to 2 locations means we're not pushing too much water in either direction also, so that if the system did get overwhelmed for some reason with a lot of water and that water rose and the rear one couldn't keep up, then in an inch of rise the front one would kick in for assistance. So, but water management is that simple. Get a barrier, stop it. The stopped water, provide a successful path, give it a place to go, but the most important thing is get rid of it. Make it someone else's problem. Water's the #1 killer of buildings. We still fail to realize that in a lot of the details we do. Anyways, there you have it. That is our water management system in the basement in a nutshell. Until next time, stay tuned.